Hello, this is Francisco from Man and Machine. I apologize for that delay. I had a little bit of a technical issue with the streaming software. Welcome to the fourth episode of Man and Machine's Fusion 360 training. Today we're going to be having a look at creating assemblies in Fusion 360. In the previous episode, we created a hinges geometry from scratch. And then at the very end of the episode, we grabbed the jaws and the pin of the hinge and used it to make a functional assembly. Today, we're going to be having a look at creating assemblies both in the bottom-up sense, where we start off with components and connect them together, and in the top-down sense, where we grab a component, we break it up into constituent parts, and then add the joints. So let's get started. Just make sure it's all working. Looking good. Lovely. Okay, so what we have here are three components that are going to be used to make up the car. So we're making a toy car first, I should probably have mentioned. So we've got a lower chassis, an upper chassis, and axle with wheels. It's a very, very simple toy, but it was actually one that I had as a child, so it's a little bit sentimental to me. What we're going to have a look at is creating an assembly, putting the components in, connecting them all up, and then modifying the components so that it makes a bit more mechanical sense. Let's go ahead and come to Fusion 360. We'll go off by clicking New Design, and before we get started on anything, we're going to save this design, and we're going to call it Toy Car Assembly. Lovely. Okay, so if you're starting from a bottom-up approach, all you need to do is click and drag components into this assembly. Now, the components can be singular parts themselves, or they can also be sub-assemblies. It doesn't really matter. Let's go ahead and click and drag lower chassis into the assembly. Lovely, there we go. We have the ability to click and drag these arrows and move these little circles to translate and rotate the component in place, but we're going to go ahead and leave it all at 0 and click OK. Now, beautiful, we've got a single component in our assembly. At the moment, what we have is the ability to move around this component. Now, when it comes to assemblies, proper practice is to have at least one component grounded in place. This keeps it fixed and in control. Let's go ahead and right-click this part and click Ground. Ground is very, very useful in that it stops that part from ever moving. You can notice that it's grounded because you'll see a little pin on the component icon in the list. Lovely. Let's go ahead and add in the other components. Next, what we want to do is add in the upper chassis. So to do that, we'll go ahead and click and drag it in. And there, it's thrown in the component in some random place. Using these arrows or using that center circle or using these side circles, we can rotate and translate this component. For our exercise, it doesn't really matter where we put it in at the beginning, because what we're going to start off with is a joint that will connect the two together. We'll go ahead and click OK. And here we've got two components now in our assembly. We've got the lower chassis and the upper chassis. So the upper chassis is free to move around in space, not very useful mechanically. But one thing that you might have noticed that's a little bit strange is that the component, when you move it, creates these two icons at the top right. We've got capture position and revert. Now, Fusion 360 is very powerful in that it allows us to add features to the assembly level. That is to say that we wanted to drill a hole through both of these components. But in order for that feature to make sense, it needs to know where the components were relative to one another when that feature was created. So to that effect, it wants to know whenever you translate something, do you want to capture that position? For now, we're going to ignore that. Just click revert, and we'll keep it the way that it is. So these parts are conveniently designed. What we want to do is connect the top chassis to the bottom chassis using a joint. So we'll come over here to Assemble, Joint, and what we're allowed to do, what we can do, is click a point of interest on the top chassis. Typically, it's the center point or the side point here, and the dialog allows you to choose the orientation as well. Fusion also allows you to choose mid planes. So say, for example, you've got two separate sides of this and you want to choose the center plane, you can do that. But for now, we'll just choose a simple mode. We'll mouse over the front point of the top chassis, making sure the circle is facing that, like that. And we'll mouse over the bottom chassis's front point as well. Keep in mind, when we choose the front point, we can choose the orientation of that point as well. So that point is facing upwards, that point is facing forwards, this one is facing axially. Let's go ahead and make sure that that point is facing upwards. We click, and oh, it's trying to be clever. It's inferred that we want a rotational constraint between those two. What we want to do is change the type of joint. So we'll come to the second tab here, motion, and here we'll change it from the revolute type to the rigid type. And what we're telling Fusion then is that we want these two components rigidly fixed together. If we hypothetically wanted them at an angle, we could use this dialog here and fix them at that angle, but the car is conveniently designed and we don't need to play around with any of that. So there we go. We'll go ahead and click OK. And now we can see that the top component, if I try and click and drag it, isn't moving anymore because it is rigidly fixed to the bottom component. You might have noticed as well that a little icon appears here. This is the icon for a rigid joint. At any time, you can inspect all the joints by expanding this branch in the tree and finding underneath rigid one. If you want to, at any time, you can rename these components. You might say rigid 1 dash bottom chassis to top chassis, if you want to be pedantic about bookkeeping. You can also make the joints visible and invisible by toggling this little eyeball icon here. So we'll click the eyeball and the icon will disappear. Lovely. All right, so pretty good so far. Pretty great car, except it has no wheels. Pretty bad car. Let's go ahead and add in some wheels. To do that, all we'll need to do is click and drag two instances of this wheel component into our subassembly. So we'll go ahead and click and drag. Lovely, and there we go. We've got our first set of wheels. I'm just going to click and drag it and move it out of the way so that I can go ahead and click and drag another. If we want to as well, we could also right click and say copy and paste in a second set. That's the same as dragging it in from the side there. All right, so what we want to do is we want to insert these wheels into these sockets here so that they're free to rotate. Now, in order to get them into place, we might want to hide the top chassis just to make it a bit easier to work. To do that, all we need to do is highlight chassis and click this eyeball icon here to toggle its visibility. Next, we're going to go ahead and we're going to click Assemble and Joint. As before, what we're going to do is pick 2 points of interest. The first point will be the center point of our axle here. And the second point will be the center point of this socket here. Now, because our last joint that we created was a rigid one, what we wanted to do is change it so that it's a revolute joint. To change it so that the wheels can rotate in place. Let's go ahead and click Motion and click Revolute. And from the animation, we can see that it's free to rotate in place. Very good. Let's go ahead and click OK. Let's go and do that one more time. The shortcut for joint is J, by the way. So if you see me doing it by magic, it's the J button. The J button is magic. Let's go ahead and click Joint. And we'll click the 2 points of interest again. So we'll click the center of that shaft there and the center of that socket there. And again, it's inferred a revolute constraint. At any point, we can add an offset if we want to have the wheels offset to one side or another side, or for whatever reason. But we're going to leave it at 0, 0, 0. And we're going to click OK. So lovely, we've got 2 sets of wheels, we've got a top chassis, we've got a bottom chassis. Our toy is looking pretty good, except entirely that it won't work because there's no clearance on the wheels. So what we're going to have to do is make some modifications to this design. The first modification that we're going to make is we're going to make these wheels a little bit larger. The second modification is that we're going to make this shaft a little bit smaller because from memory, the size of this shaft is equivalent to the size of the hole there, which means that it won't actually be able to rotate in real life. So, unfortunately, because this is a bottom-up approach, editing the component isn't so easy as it would be if it was a multi-solid body. If it was a multi-solid body, we could come over here and we could say, let's go ahead and say press pull. and we could choose this surface here and make the wheel larger, but the component isn't in this assembly, so it is its own component. However, a new functionality has been added that we are able to edit it in place. And like a pro, I don't think I've enabled it. Maybe not. That's okay. We'll go ahead and we'll edit the component independently. So let's go ahead and open up the wheel by double clicking it. Lovely. There we go. So this is an imported component from Autodesk Inventor, so it's just a dumb solid at the moment. There are no features at the bottom that we can edit. Now, I always find that when you're editing these imported components, what's really, really beneficial is to enable the timeline at the bottom here. The timeline keeps track of all of the features that we are adding to this component to make it what it is. So when it's imported, by default, that timeline might be switched off. To turn it on, we'll right click at the top here and we'll say capture design history. I cannot stress to you how useful this is. Definitely do it. Click capture design history. And there we've got our familiar timeline at the bottom. Our first feature is a base feature. It just means that the geometry was imported from another language. All right, so what we want to do is make these wheels a little bit larger. There's lots of ways that we could do this. We could use offset surfaces, we could use extrusions, but we're all about that lazy life, so let's go ahead and use press pull. By clicking press pull, we can click on these surfaces, and using this arrow, we can click and drag to make the wheels larger and smaller. Fusion's very intelligent in this way. So I'll hit escape, and we'll try it again, press pull. And what we're going to do, it's read that the radius is 25 millimeters. What we want to do is make it 35 millimeters. So we'll click and drag. We'll type in 35 millimeters. Oops, I should probably select both the wheels. There we go. Click and drag and make them 35 millimeters. Lovely. And we made the wheels slightly larger. I'm going to go ahead and save that. And then without closing the wheel, we're going to go back to our toy car assembly. Now you might notice that the wheels in the assembly haven't become any larger, they're still the same size. However, there's a new icon that showed up here. Get all latest. What that says is that some of the components have been updated and that it's asking for permission to update them in the assembly. So we'll go ahead and click Get All Latest. And it will grab the latest version of those wheels. Looking pretty good. I should be a toy car designer. Now, the second thing that we want to do is make these wheels, the axis of these wheels, a little bit smaller so that they'll actually fit in the hole. To show you what I mean, I might just hide that axis. And I'll use the Inspect tool to measure this hole. We can see that the hole's diameter is 16 millimeters. And we can see that the axis of the wheels is also 16 millimeters. So to make it rotate in place, we might want to reduce the axis of the wheels wheels to say 15.8 millimeters. So to do that, we'll go along here, and once again, lazy press pull. Here we can change the diameter. So what we've got there is the original. What we've got there is the original radius, 8 millimeters. So I might have to change the radius to 7.9 millimeters. If we use the Inspect tool now, we can see that the diameter is 15.8 millimeters. Lovely. We'll go ahead and click Save. Go to our toy car assembly. And once again, click Get All Latest. And if you were very eagle-eyed, you might have noticed that that shaft became a little bit smaller, so it's able to rotate in that socket. Lovely! Childhood achieved! That was a fantastic exercise. Let's go ahead and save the toy car and close it down. Okay, the next one will be a little more. We'll go back to our hinge. Actually, no, let's look at these pliers. We're going to go ahead and we're going to create an assembly that is a set of pliers. It's going to be a very, very simple set. This is going to have three components. The left handle, the right handle, and a pin to keep it all fixed together. So as before, what we're going to do is create a new design, and we're going to save it. So we'll click Save, and we will click Pliers Assembly. We'll give it the name Pliers Assembly. Lovely. Once it's saved, we can go ahead and we can drag all of the components that make up this assembly into our assembly. So we've selected them all by holding down Shift, or you can hold down Control and select them individually. So click them all and drag them into the assembly. There's the first component. Oh, sorry. For the first one, it just allows the first component. I'll go ahead and undo that, and we'll just drag in the pin because I want that to be the first component. Come on, computer. Oop. You can do it. Yay, there we go. Lovely. So we've got our assembly, and inside we've got our pin component. Now, we don't really need to mess around with its orientation, but we will. So let's go ahead and drag this circle so that it's facing upwards, 90 degrees. If you look at the view cube, we've got the pin now facing to the top like that. Go ahead and click OK. And as before, what we're going to do is ground it in place. So to do that, let's go ahead and find the pin, and we'll click ground. This just prevents the pin from moving around. Let's go ahead and grab the handles and drag them in. Oh, so there's the first. I'll hit cancel. We'll do it one at a time. Left handle first. Just thinking about life. There we go. And I might just change its orientation and move it to the side. And the right handle. Lovely. So let's go ahead and connect these all up. Let's go and click Assemble, Joint, and here we can choose a point of interest. Now this time the point of interest doesn't actually exist on the surface, but Fusion's very, very clever, and it assumes that you want the center point of this circle. Now to reach it, you've got two options. You can either mouse over the lip and it will infer that you want the center point of that circular loop, or alternatively, you can hover over this face, hold down the Control button, and it will snap to that face to points of interest. So if I rotate the view, you'll be able to see it a little bit better. There we go. I can rotate and select the center point of that circle there. Now, to make this work, I'm going to need this side and connect the center point of that circle there. And what I want to do is connect it to the bottom face of this pin at the center there. Oh no, catastrophe! It's come in at the wrong orientation. It's not the end of the world. In order to flip it, all we need to do is click this button here, and it will flip the orientation. Lovely. Okay, let's go ahead and click OK. And next, we'll do the same on the other side. So we'll go ahead and click Assemble, Joint, mouse over this top face, hold down Control, or let's go ahead and choose the center axis this time. Center axis, and we'll choose the pin center axis as well. Lovely. Again, it's coming at the wrong orientation, but that's okay. We'll go ahead and click Flip, and it will bring it in to the orientation that we require. Okay, it's looking a little bit unhealthy, a little bit ghostly. What's happening here? We've got the components going through one another. At any time, if we suspect that the components are going through one another, we can come along here, we can say Inspect, Interference, and for the sake of this exercise, we'll go ahead and click Capture Position. It will remember the position of those jaws as they are. Select all the components that we want to analyze, and say Compute with this icon. And it will highlight in red beautifully where the assembly is intersecting itself. We can see that the jaws are going through each other. Not good. So let's go ahead and drag them out of interference. There we go, looking good. Because the center pin is fixed in space, these guys are able to move around without the whole assembly flying off. Now, say that we want these components to run into each other. That is to say that they're allowed to move around, but they're not allowed to go through each other. In order to do that, what we're going to do is turn on contacts in the assembly. Contacts can sometimes be computationally a little bit difficult. So typically they're switched off, but if you switch them on, the computer, whenever you make an adjustment to the geometry or to the positions there in the components, it will try and calculate, are these components running into each other? If so, then do something. So let's go ahead and come to assemble, and we're going to click enable all contact. What we can now see is that there's a new addition to the list here. It says contact all. Now we can click and drag the jaws as before, but look at what happens. How cool is that? They're actually functioning. So cool. So the components in the assembly aren't allowed to interfere with one another. So if you've got something that depends on motions in the assembly, so say for example these pliers, and you want to make sure that it makes mechanical sense, you can turn on contacts and you can have the components move as they would in real life. Lovely. I might revisit these pliers later with a stress analysis. We'll go ahead and save that and close it down. Okay, so let's go ahead and have a look at, we want to have a look at, which one? The hinge. Let's go ahead and use the hinge from the other day. Now, this hinge is a little bit different from the other components that we dealt with today. The other components, like the car and the pliers, each of the components inside were individual parts, and we use those parts to make up an assembly. But this hinge was a little bit different, because we created all of these components feature by feature. Now, if we roll back the timeline, back to before we made them components, these were all just individual bodies. They weren't parts. They can't move relative to one another. But we were able to make, we were able to make them. I'm just going to go ahead and delete everything after the timeline. We were able to make them into separate components by doing the following. So we grabbed bodies and said create components from bodies. What this is doing is turning the multi-solid body component into an assembly. So we'll say create components from bodies. And now we've got 3 separate parts. Now, what we might want to do is we might move them just arbitrarily like that and capture the position. When you capture the position, a little icon gets inserted into the timeline just to say, hey, I remember that these were moved to here. Now, as with all the other assemblies, it's good practice to have one component, at least one component grounded. So we might say, grab that pin, right click, and say ground. Beautiful. So these components can now move around, but that pin is grounded in space. Let's go ahead and add in some components, some joints to connect it all together. So we'll come here to assemble, joint. We don't need to capture position because we already captured it roughly before. And this time, let's go ahead and we're going to choose this kind of component selection, this kind of selection for the components. We can choose between 2 faces. Now, what this, maybe not for this one actually. Let's go ahead and choose the simple again. And we'll pick the end of that hinge there and the end of this pin here. And from memory, the clearance was 0.1 millimeters. So to add in that 0.1 millimeters, all we need to do is drag the arrow and type in 0.1 millimeter. Looking good. So far, that bottom hinge can rotate. And we want to add in the top hinge. So let's go ahead and add in a joint. Assemble, joint. Continue. Choose the top there. Choose the top there. And add in our 0.1 millimeter clearance. So does it work? Is it interfering? Let's test it. We'll come along to inspect, interference, select our components, and compute. Wonderful, no interference is detected. In truth, that's a very small gap, and there's very little gap in between here, so whether it would work in real life is up to debate, but we've got a hinge that can rotate in place. Lovely. All right, so say hypothetically I was interested in having this hinge by default be 90 degrees, that is to say open like that. A couple of ways of doing that, but the easiest way of doing it is to come along to the hinge joint. So I'll come to joints, find that connection there, right click and say edit joint. And what we can do here is edit the joint alignment. So by default, we can see by default, it's usually 0, 0, 0, but we modified the Z offset to be 0.1 for clearance at the top. If we wanted to make it default 90 degrees in that direction, we can click and drag, and we can make it 90 degrees there. Alternatively, you can just type in an angle there. Click OK. And there we have our hinge as default. We'll go ahead and click Save and close it down. Now we might make one last component. We might make a quick box, which we're going to start off as a single part, break it into lots of little solid bodies, turn those solid bodies into components, create joints to connect those components together, and then add in the hinge. Let's be fast. So we'll go ahead and create a sketch. And this time we're drawing a front of a box. So let's go ahead. We're going to make the box 160 tall and maybe 120 wide. And we'll make it maybe, let's make it 92 deep. Lovely. Very featureless, I'm afraid. Now we want to turn this quickly into a set of components. So we can come along here, modify, shell, and we want to get rid of that face there. And here we can specify a thickness for the panels. Might go ahead and say, let's go ahead and say 4mm thickness for these panels. Lovely. So we have a single box there. Now it's not going to quite work yet unless you say, made it as a single component, like with additive or subtractive. But say that we want to turn these into their own separate parts. We can do these in a whole bunch of ways. So let me just think of the laziest way of doing it, because lazy is good. Yes, very good. Okay, let's go ahead and we'll make a sketch on this face here. And we're going to go ahead and say project include. Pick that face. And then we're going to come to finish the sketch. Modify, split. Where's split? Split body. Pick the body. Pick the sketch. And what we have there is a separation between two separate bodies. Now that rear panel is its own body. So that's our first panel. We're going to go ahead and do the same for the others, but I'm going to be even lazier this time. I'm going to go ahead and just use planes. A plane there, and a plane there. Lovely. And do it again, split body, pick the master body, pick that plane. There's our second. Come here, modify, split body, pick the plane. Oh, very good. Okay, now we have, I'm just going to hide those construction planes. Tuk tuk. And now we've got, and hide the sketch while I'm at it. We're gonna, now we can see that we've got 5 separate panels. We've got the rear panel there, top panel, side panel, blah, 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 blah. I might quickly give them names. I'll say panel rear, panel top, panel bottom, panel left, and panel right. So the temptation might be to say, yay, we've done our assembly, fantastic. But it's not the end of the story. These are just bodies in a single part. So I'm going to say box. Now to turn those into their own components, we'll go ahead and right click here and say create components from bodies. Yeah, there we go. So this is going to be a really bad design, but what we're going to do is go ahead and drag away the top, and I'm just going to capture that position. What we want to do is use a glue to perhaps fix all of these panels into place. Now, the laziest way of doing it is to actually come along here and say as built joint. Now, this is actually deceptively useful. You can select 2 components, and it will just say, okay, these components are fixed in the position that they came in. So we'll say as built, rigid, that panel and that panel. It just says they're fixed together in the position that they came in. Very, very useful for quickly making these things. Assemble as built joint. Lovely. And oh, I forgot my own advice. What a terrible teacher. I'll ground one component, which will be the ground there. The last component here is a lid. Now, what I want to do is I want it to hinge on the top here. Oh, I did not think this through. Okay, it's going to be a really lazy hinge because we're running out of time here. What I'm going to do is create a new kind of joint. I'll come along here and say assemble, joint, I'll say continue. And this time I'm going to choose the center point of this axis here and center point of this axis here. And there we go. We've got a revolute joint created between those two. We'll go ahead and click OK. And at any time, we can click and drag that lid. Okay, there's more to come, but unfortunately, I'm out of time. So thank you very much for your time and energy and your attention today. I hope you're keeping well during these hard times. Stay inside, stay safe, keep washing your hands, take care of each other, and we'll get through this together because we're all in it together. So until next time, I've been Francisco from Man and Machine. Thank you very much. Goodbye.